Not every function. I know. I'm telling you, I don't know how these got so long. These were not, they didn't used to be this long. That's okay though. All right, so not every function has an inverse that is a function. Only functions in which distinct inputs always yield distinct outputs have inverses. These functions are called one-to-one. Okay, so a one-to-one function has to have, if the f of a equals f of b, then a has to equal b. So basically you can't repeat x values or y values. And there was that question on the quiz yesterday about those prime number things and trying to decide if it was a function or not. Right, that one. So that whole idea of can you repeat x values or can you repeat y values? And some of you switched it around, and in your explanation you wrote, it wouldn't work because you would be repeating these values. Well, those were y values you were repeating, and y values were okay for a function before. But if we want something to be one-to-one, we can't repeat x values or y values, okay? In order to do this, we're going to verify algebraically on these first ones. I'll show you kind of how that step works. And then we will walk through how it looks on a graph when you're doing it, okay? So if they are one-to-one, you can also do horizontal line tests. Where is that? Oh, that's on the back. Okay. So horizontal line tests will also work to see if it's one-to-one. So if f of a equals f of b, then a has to equal b. So basically what I'm going to do is I'm going to plug in f of a. I get 2a plus 1, right? And then f of b is 2b plus 1. And if I set these two equal to each other, 2a plus 1 equals 2b plus 1, and I start to solve this out, right? And I divide. And I end up with a equals b. Check. So I have verified now that this is, if f of a equals f of b, then a equals b. And so I'm good. I'm going to do the same thing. So this means it's one-to-one. Yep, that's what we're doing. Okay, so you could say, yes, it is a one-to-one function. And if you think about it, it's a line, right? So the line doesn't have any repeating x values or repeating y values. For every x value you put in, it has a distinct y value and vice versa. All right, so b, do the same thing. Go ahead and do f of a, f of b, set them equal to each other. This is a parabola.
So wouldn't it automatically not go to
Well, I don't know. Let's see what happens.
What's the point of this?
Come on, you know my answer.
Because I can go look.
Oh, no. One-to-one functions? That's not going to be on there.
Just look at it.
Okay, so I just started right away with doing A's and B's here, right? And then I'm going to take square roots of both sides.
Is it plus or minus?
No. Because they're both square roots, you don't have to worry about it. So it did work out to be one-to-one. Okay, so if we think about the graph of this, and I'll talk about the horizontal line test on the other side here. Right? Oh, I know why. Okay, if we take its inverse, then its inverse would also be a function. And so that's all that one-to-one is telling us. So I take back what I said about the distinct y values. You can repeat y values here. The issue is going to be if I do the horizontal line test. Oh, no, the vertical line test works. This one should be a no. Why did this work out? This should be a no. All right, guys, figure it out. What's wrong? What mistake did I make? The plus or minus? That shouldn't matter, though, because it's plus or minus on both sides.
You think I know? You're the magic.
I know, right? All right, this should not be one-to-one.
Oh my god.
All right, I will go back and figure out why. Aren't you writing in pencil?
Yes.
I need my white out. So I'm going to go back and figure out why that one should not be one-to-one. Because you're right, it shouldn't be one-to-one.
If it's plus or minus, wouldn't one be plus
plus and then the other
Robbie, what does it say?
But see, they both can be. No, this isn't on the answer key. These are new. Yeah, these are new notes.
More possibilities that they could be.
Maybe it's just a bad example.
Because then you could do the plus and minus. Yeah, that could be it. Yeah, that could be the plus or minus issue. Because if we're going to do, so then you'd have like plus or minus. And then the plus would have to equal the minus, and the minus could equal the plus possibly. And that wouldn't work.
Can I get candy? Because I was right.
Buy your own.
Sure, miss. I want healthy treats. Come on.
Oh, every single piece of candy I have from your class is in my lunchbox. I have like 3 pieces of candy in there.
You gotta save them. All right. So let's talk about the domain and range. I'll come back to this one. I think it's the plus or minus. I think you guys are right on that. But let me go back and see. This is not a one-to-one function for sure. All right. Let's go to the next one. Yeah. Right. All right. So domain and range. Let's go through here. X plus 3 minus 2. So this is the same graph we just did, right? So you guys know this is shifted left 3 and down 2. Left 3 and down 2, right? So this is my graph. So what is its domain? All reals. What is its range?
I'm kidding. 0 to...
Not 0. -2. There we go. Good. -2 to infinity. Okay. The graph of its inverse, use answer from example 8b. Well, we didn't find the actual inverse there, so that's not going to do it. So let's actually find the inverse. I want you guys to do the exercise, work through it. You've got y equals x plus 3 squared minus 2. Switch x and y and find its inverse. And then look up here and check your answers. All right, so did you get this for its inverse? -3 plus or minus the square root of x plus 2. And here you do need the plus or minus. Okay. What would be the domain of this function? Not all reals because I've got this radical in here. So since the radical's in there, yeah, so we want to start with -2, right? This would be x plus 2 has to be greater than or equal to 0. So x has to be greater than or equal to -2. So my domain would be from -2 to infinity. Okay. What would my range be? That would be all reals. Now, what do you notice about domain and range here? Yeah, they switch. Does that make sense? Well, yeah, because in order to find the inverse, I just switch my x's and my y's. So my original domain is now going to be the range of my inverse. My original range is now going to be the domain. Okay? What does this graph look like? A sideways parabola. Yeah, you got it. It's a sideways parabola. Where does it start? I might start at -2 here, right? Yeah, -2, -3 down here. And it just does this sideways thing. So this is the positive square root. So this is like the -3 plus the root. This is the negative square root. So that's why you have both of them. And you do need the plus or minus. It is going to give you both because we want that complete reflection. Notice these two would be reflected over that line y equals x again. All right, what's the relationship between domain and range? Well, we just said this, that they're switched. It just says that they're switched. Okay? All right, let's try the last page. I know these are like speedy. And we're going to talk about horizontal line test. This is the way to figure it out by graphing. It's 1-to-1 if and only if the horizontal line intersects it at most 1. So let's just sketch the graphs. Negative 1/2 x plus 3. Go ahead and draw that. So horizontal line test would just go through like this, horizontal lines. Notice I'm only touching my graph everywhere at one point. So I would say, yes, this is 1 to 1. For this parabola, how does it get flipped?
Upside down.
Flip over x, and then minus 2 would be down 2. So try your horizontal line test, and crosses 2 times, right? So no, it's not 1 to 1. And again, all that 1 to 1 means,
Why did they bring out yes plus or?
it shouldn't have. That's why I said it was a mistake. That one was a no. That was a no, right? We erased it. We said it was wrong. It should have been no. Okay? So what does 1 to 1 mean? 1 to 1 just means that if you take its inverse, the inverse is not a function. And that makes sense because if I take the inverse of this, it would turn on its side. And a sideways parabola wouldn't pass my vertical line test. It would not be a parabola. Okay? If you take the inverse of this, it would be a line, and it would be a function. Okay, let's try this one. Square root of x to the 4th. What do you think about that one?
I don't.
Why is it just x squared?
Well, yeah, you're like, wait, doesn't that just cancel and just give me x squared, right? Well, kind of, but remember we have to talk about domain here. So I want to look at the domain of this. What's the domain of that inside one? For square root of x, it's just 0 to infinity. Very good. So I can only take 0 to infinity, right? So it is going to be the graph of x squared, but with this domain. So it's only going to be these positive values of x squared. So now is that function 1 to 1?
Yes.
Yeah, and this one would be 1 to 1. And so it does make a difference the way you write it. If I had just written x squared, it would not be 1 to 1. But since I rewrote it as radical x to the 4th, using that original domain, this in case would be a 1 to 1 function.
So always keep domain in mind.
Yes, always keep domain. All right, this last part, we're going to talk about inverses now when we're shifting these segments. And so I want to get you through this last one. Let me see how long I'm going. Okay, I should be okay. All right, so this is very similar to what we did before with shifting left, shifting right, up, down, flipping, all that stuff. Except I'm going to add in there now the inverse. Okay? So what would it mean for that step of taking the inverse? Switch your x and your y. When you're doing these transformations, I always want you to do the inverse first. Okay, so let's write out our steps. First step will be take your inverse. So first step is to switch x and y. So first step is inverse, switch x and y. So instead of 4, -1, I'd have -1, 4. Literally switch. And here instead of 2, 6, I would have 6, 2. Okay? Then I'm going to go through all my other steps. Well, this needs to factor out a negative here. And I still have some of you not factoring out those negatives on your quiz yesterday, and that really hurts you. Because there were like 4 of them that you had to do it with. So you have to factor out that negative. It's going to change the direction you go. You're not going to go right. You're going to go left. Okay? So this negative tells me to flip over which one? Good. Which means change sign of x. Okay. So -1 now becomes +1. +6 now becomes -6. Now I can move it left 3. So -3 from my x's. And then I can go up 4 and add 4. And you should be at -2, 8 and -9, 6.
I have a question.
Yes, ma'am.
Okay. Does it matter what order you go in? Because in the book it said it didn't matter, but you told us it did.
It does matter if you're doing the factor out the negative. So the book doesn't do the factor out the negative, What they do is if you don't factor out the negative, then you go the opposite direction. So they do this whole other thing, whereas if I do it when you factor out the negative, you still go that same direction. But if you factor out the negative, then yes, order matters. So trust me. Do what I say. Ignore your book.
I mean, I've always been interested.
That's good. Yeah, so the book does have another way to do it. I think the way the book does it is a little more complicated, and I've had students get more confused doing that in the past. So now we've sort of just changed it, and we just do it this way, and I think it's more clear. So that's a good question, though. I know it's confusing when you hear two different things. So yeah, order matters. Always do inverses first, then do your flip, then do your left and right, and your up and your down. Okay, so for this one, I would switch X and Y. Go ahead and try it, and then just look up and glance to make sure you're on the right track. Is that what you got? Perfect. Okay, good. The last part is just an example of how we would graph it now with the inverse and a transformation. And this is what you're going to practice in the packet in a little bit. Okay? So again, now you're going to do the same thing you're doing here, but you're going to then graph these, right, with all these transformations. After you're graphing, again, first with graphing, I want you always to graph inverse first. Always do the inverse first, okay? So in this case, the original graph was 2x minus 3, okay? So I can graph that one if I want. This is negative 3 up to, this is my parent function. Now for me, it's a lot easier to actually find the inverse by hand. You could try and start flipping all these points and graph it here, but it won't be as accurate, my guess is. So let's actually find the inverse first. Switch X and Y. And notice how I wrote it like this, just because now it's in mx plus b format and it's easier to graph it. So this is my inverse. Oh, this was g, sorry. So g inverse was 1/2 x plus 3/2. So there's my inverse. Now, though, I have to shift it. So how does this one want me to shift it? Up 1. So after I've done the inverse, now I shift everything up 1. Since it was originally at 3/2, it shifts up to 5/2. And this would be my new line. Right? So what did I do? This was the original. I found the inverse first, and then I did the shift on it. Shifted it up. Try that next one. You already found the inverse, so you're using this equation as your inverse, and then you need to do these shifts on it. And again, after you work, look up to check and see.